So we got a peek at this one in the last video. This is where we're going to start, so see if you can figure it out. So if we want to know the slope of the tangent line, that means we need the derivative evaluated at the point. So how do we take the derivative of this? So the first thing I would do is rewrite it. Oh, that's one of the ones we did yesterday in the previous video. So the f prime of x is negative e to the negative x. So negative 1 times e to the x. So there's our derivative. We want to evaluate it at this point. So f prime at negative 1 equals negative e to the negative 1, which is negative e to the first power. And so that's our answer. So that's our slope of the tangent line, which is what it asked for. And so we're done. If it had asked for the equation of the tangent line, we would write y equals negative e parentheses x plus 1 plus e. So that's our tangent line. Just for practice, it didn't ask for that. It's good practice stuff. All right, so let's get into it, see what's going on today. So, we're skipping that. We're talking about our natural exponential function, or e to the x some more. We've already taken the derivative. We know that the derivative of e to the x is e to the x. So now we're going to integrate. And integrating is a little bit harder. Oh, wait, that's a lie, because there's nothing hard here. But it can get tricky when you have compound functions. We'll get into that. So if we go backwards, we integrate both sides. We take the integral of both sides. And so the integral of e to the x dx is e to the x plus c. It's even better than the derivative because integration is harder than deriving. We know this. It's harder to integrate than it is to derive. And so it's nice when it isn't, when it's the same, when it's just the same. So let's see what we can do. So let's go ahead and do some practice problems. So that's what we've got here. So we've got our integral. We know it's going to be, excuse me, that went too fast. So we've got e to the 2x, because that's what's going to happen, divided by the derivative of that. So it's 1/2 e to the 2x. So we always divide by the derivative of our exponent. And there is our answer. Don't forget plus c. All right, so let's see what we got. So now we've got this slightly more complicated problem. And so let's go ahead and start with u. Let's let u be x squared, and therefore du is 2x dx. And so there's du. And this was u. And so it gets rewritten as the integral. Let's rewrite it in blue. The integral of e to the u du, which we know is just e to the u plus c. And so u was e to the x squared plus c. And there's our answer. That's all there is to it. Nothing complicated here. So it's your turn to try. We've done a couple of different examples, so let's see what we can come up with. So pause. Let's just go put it out there. Go ahead and write it down. And we'll do the answers in a minute. I think this would be a good place for you, sub. So I'm going to pause the video to write down the answer. You pause too and see what you can come up with. So I started with u equals x cubed. Du then is 3x squared dx. So I needed to put a 3 right there, so I could put 1/3 in the front. And so that being done, then I take my integral. 1/3 e to the u plus c, which becomes 1/3 e to the 3x plus c. Next problem. All right, again, go ahead and pause. This one's a little bit trickier. So maybe let's not pause yet. Let's stare at it for a minute. Okay, the first thing to notice is that we've got the natural log of e to the 2x minus 1. And we know that the natural log and e are inverse functions. So we can make this complicated or simple. I'm going to go ahead and simplify before we start. We've got our integral of 2x plus minus 1 dx because these two undo each other. And so making this problem fairly straightforward. Otherwise, we have to do some u sub and do some crazy stuff and think about, okay, so what's the integral of ln of x? And we actually, we're kind of at a loss right there still. So let's figure out here. We've got x squared minus x plus c. This just take the integral of each piece. Very straightforward. Don't let stuff like this get your way and confuse you, because there's no reason for it. Looks complicated. What should we do? So go ahead and pause. Again, I'm going to suggest u sub here. Pause this video, see what you can. All right, so I used u substitution. I've let u equal 1 minus e to the x. The derivative is negative e to the x dx. And so I've plugged everything in, put it in the negatives there. And, your basic power rule here. And so final answer, negative 2/3, parentheses 1 minus e to the x, close parentheses, raised to the 3/2 power plus c. So pretty straightforward. And let's try another problem. So for this one, we're going to be trying to find the particular solution for the second derivative of this function. And so we've got some initial conditions. The f of 0 is 1 and f prime of 0 is 0. So let's go ahead and do some integration. So we've got the integral of 1/2 parentheses e to the x plus e to the negative x dx. And so that gives us 1/2 e to the x minus e to the negative x plus c1. So that's our first derivative. So that's f prime. So we'll go ahead and plug in our initial condition that we get 0 when we get 0. So 0 is equal to 1/2 e to the 0 minus e to the 0 plus c1, which is 1/2 of 1 minus 1 plus c1. So that's 1/2 of 0 plus c1. And so c1 is 0. And so we have the integral of 1/2 e to the x minus e to the negative x plus nothing, so plus 0. So just put dx on that. And so we take our derivative again, and we get 1/2 e to the x plus e to the negative x plus c2 is equal to f of x. And so we know when we plug in 0, we're going to get 1 this time. And so we will have 1 equals 1/2 e to the 0 plus e to the 0 plus c sub 2. which is 1 equals 1/2 of 1 plus 1 plus C2, which is 1 equals 1/2 of 2 plus C2. So that's 1 equals 1 plus C2, which means that C2 is 0 as well. And so our particular solution, which we'll write at the top in this light blue color, f of x is then equal to 1/2 e to the x plus e to the negative x. And that is our answer. So it's pretty straightforward. Again, not much trickiness here except for the two initial conditions integrating twice. And as you can see, all that really changed in our integrals here is the plus and minus sign in front of in between our two problems. So let's see what we got going on next. So now we want to find the points of inflection, which means we want to find the second derivative and set it equal to 0 for possible points of inflection. And so f prime of x is equal to the first times the derivative of the second plus the second times the derivative of the first. Clean it up just a little bit. Negative x e to the negative x plus e to the negative x is f prime of x. So now we're going to find f double prime of x. And that's first times the derivative of the second plus the second times the derivative of the first plus the derivative of our next term. And cleaning that up, we get positive x e to the negative x minus e to the negative x minus e to the negative x, which is x e to the negative x plus minus 2 e to the negative x. Okay, and so that is our second derivative. We need to set that equal to 0. So let's just clear this out a little bit. And leaving with our second derivative here. Which now we need to set equal to 0. And I'm going to go ahead and pause this and see what we can. So what I did here is I set it equal to 0. I factored out e to the negative x. So then I set each part equal to 0. 0 equals e to the negative x. That's never going to happen because e to the x will never be 0. And then 0 equals x minus 2. So 2 is a possible point of inflection. I checked the sign, and the sign when I'm smaller than 2 is going to be a negative number. And when I'm bigger than 2 is a positive number, and therefore 2 is our point of inflection. Point of inflection, x equals 2. And so that's our answer. And good luck with e to the x. It's super fun. It can be a little challenging, but it is super duper duper fun to use.